It starts with a tiny piece of coral lifted from the sea. Cut, attached, nurtured. Taken from the ocean, brought into care, and one day returned. Coral reefs around the world are under pressure. And Singapore is trying to restore its own by growing corals at a scale never attempted here before. How do they do it? And will it work? Coral reefs are some of the most important ecosystems on Earth. They shelter marine life, support food sources, and help protect coastlines. But more than half of the world's reefs are already gone, and the rest are under growing pressure.
Human-related stresses, coastal development is one of them, but the greater threat are like the global heat waves that come in. We have no control of that. So recently, we had the 4th global coral bleaching event that occurred in 2024. Animals and plants can die due to the rising temperatures in the water.
When reefs weaken, the effects ripple through the ocean and into our lives.
If you go to the market and you look at the seafood, almost all the species that you see there have some kind of link to the coral reef. So they're immensely important for food security. They're amazing coastal defense structures. And we are looking at how nature uses these features to protect coastlines, and we're trying to mimic that and use that in the way we find solutions to protect our coastlines.
And to save reefs, it starts with the organism that builds them, coral. Karen drives the work behind Singapore's reef restoration efforts. In 2024, Singapore launched the 100K Corals Initiative, a decade-long effort to grow and prepare 100,000 corals for restoration.
Are they plants? Are they animals? Are they mineral? They're all three. They are the foundational organisms in a reef. They actually build the structures that create coral reefs.
Growing new corals begins in the ocean. Researchers collect small, living pieces from healthy colonies, tiny fragments that can be grown into many more back in the lab.
There are many ways to restore a reef, and there are many methods. So one of the simplest methods is fragmentation. Again, corals are simple animals. They grow from small little fragments. You can break a coral that's a few millimeters in size, and if you take good care of it, you give it the right environment, it can become a coral that is 10 centimeters in 2 years.
We want to take the best care we can for them. Right after we harvest them, we actually have to do several water changes. We have to make sure it doesn't get too hot on the deck as well, so we are constantly checking the water.
Jerome leads these offshore coral harvesting missions.
It's a long way back to the aquarium, so we also want to, afford them the best care.
Back at the St. John's Island laboratory, every harvested fragment is monitored under controlled conditions. They become part of the foundation stock, the living supply the team uses to grow thousands more coral for restoration.
We got 5 different species across the reefs, and for each species, we collected at least 3 different adult colonies. So that gives us some genetic variants as well.
One of the newest arrivals is a vulnerable species.
That means there's a threat status assigned to it, and that will be Platygyra. This is another species. It's called Leptoria. It's a very nice maze-like pattern.
Bringing in more genetic diversity broadens the range of corals Singapore can restore and improves the chances of growing corals that can adapt to changing oceans.
So we spent quite a bit of time making sure the aquarium is completely 100% able to support the number of corals that we want to grow there. and the aquariums are running at full capacity now.
Here, the fragments settle in and acclimate. After a few weeks, the real work begins. They are cut into smaller pieces in a process called fragging. Each one becomes the start of a brand new colony.
Our tanks here can take up to 3,600 coral nubbins at any one time. We are trying to ensure like a constant flow.
It's a continuous cycle. Corals growing in the tanks, corals being planted back at sea, and new fragments arriving to take their place.
That means we always have stuff that's growing. The moment we outplant, the moment there's space, we have these harvesting trips that bring in new corals to propagate and to restart the process all over again. We need to restore Singapore's reefs at a scale large enough to ensure that the reef is resilient.
The 100K represents the number of individuals that we will place on the reef. So 100K is a number that sounds ambitious because we have an ambition to ensure that our reefs remain healthy and resilient over a long period.
But planting corals is only half the story. Knowing where to plant them is just as critical.
Before we outplant, there are baseline surveys that we do. We would first check out what's there on the reef. We'll first check out the species composition, the diversity. We'll see if there's anything stressing the existing corals at the reef. And we take note of their growth rates and how they're doing, at least for the first year. We have seen very good survival from the corals that we've planted. We back it up with very robust scientific practices.
We've lost a lot of our coral reefs. What we have remaining now is 10 square kilometers. What we're looking into is how to make corals more resilient, or how to make sure that we're able to identify the naturally resilient corals for reef restoration efforts down the line.
Jerome's team brings the corals in.
Yanni's team finds which ones can handle rising heat.
We call it the coral gym, so we're exposing the corals to heat intensity and interval training to try and see if this would be something that would make them more resilient, with the hope that they will be able to have this physiological memory. So if the next time they are exposed to this kind of heat stress, they won't react as badly.
In this gym, the corals face a trial designed to mimic warming in oceans of the future. 12 hours warm, 12 hours cool. Stress. Recovery. Then stress again. For nearly a month, they train in this cycle. Then comes the final test. Researchers increase the temperature by 1 degree a day for a week to see which ones endure.
We do push them to their tipping points, the maximum they can take, where their photosynthetic efficiency goes down to like 50% or is half. We don't know if it works yet. We're also trying to find what would work for Singapore's coral. The take-home is that there are already individuals that are naturally resilient. What we want is to identify those that are already naturally fit and prioritize culturing those and use those for transplantation as well as part of the 100K Corals initiative.
Heat isn't the only factor that decides whether a coral survives. Scientists are now looking at something much smaller, the microbes living on them.
Corals actually have their own probiotics living on them. One of the things that the scientists are showing is it may not just be the corals themselves. It could be the microbial community that lives on the corals. Can we understand what kind of microbial community might confer some kind of protection on these animals when an event occurs? And if we know what these are, introduce them to other corals in aquarium. So basically our 100 corals get a boost of probiotics before we move them out to the sea.
Survival rates for transplanted corals used to be just over 10%. But in the last 2 decades, that has changed. With better methods and strong corals, survival now reaches 80 to 90% for some species.
From the research that we've done, knowing what species to plant where, what size to outplant them, what environmental conditions they need. So all this science has translated to, we can do a large-scale coral reef restoration effort for Singapore. It is going to be viable.
And when corals return, the rest of the reef follows.
We've outplanted, I think, about 1,000 coral fragments. What we want to achieve from this is not just moving 100K corals out onto the reef, but along the way, build resilience in these corals to the research that's being undertaken now. We're trying to find solutions so that they will be around in the next 50, 100 years.
Coral restoration is precise work. The right species on the right site. Fragments grow into colonies. Colonies shape reefs. And reef by reef, a living coastline begins to rebuild itself. This is how Singapore restores its reefs, one fragment at a time.